Welcome back, friends. So this looks extraordinarily similar to the previous one because I used the same equation and put a +1 at the end. And the reason is quite simple. I think what a lot of students try to do is they start blindly applying mathematical principles to equations. Like very often in the last one, they did something called cross multiplication, which means that they multiply the x times the 1 and then the 3 times the 10, and then you're done. And they want to apply that logic to every single problem. And you can do that as long as you have the correct setup for that. I mentioned in class that you have to have a proportion in order for that to work. This is not a proportion. A proportion is a fraction equaling a fraction, not a fraction equaling a fraction plus something. So if you rewrite this as a proportion, then it's legit. So rewriting this as a proportion would be 3 over x equals, that's 10 over 10, 11 over 10. So now you can go ahead and do whatever you want to do as far as cross multiplying or whatever you want to do. But I'm going to stick with the whole Lego methodology. Because now that you've written the equation like this, it is the same format as the other problem, right? I mean, you've got an x that was inverted and then multiplied by 3. So the first thing you're going to do is you're going to divide both sides by 3. And you're going to end up with 1 over x equals 11 over 30. And then you're going to invert both sides. X over 1 equals 30 11ths. Looks very, very similar to the previous one, with the difference of the 11th because of this extra little guy. It's the extra little 1 over here. So if you can, the reason I find the Lego methodology so appealing is that it'll work for any equation as long as you know how to invert. And you know how to invert linears. It's a piece of cake. We'll learn a few more ways in class how to invert other stuff too, but we'll get to that in time. But pretty straightforward again. We'll look at the next one, which is a little bit more interesting.